This section is 6.4. We're going to look at the volume of prisms and cylinders. So the learning goal for this section is, of course, students will understand how to calculate volume of prisms and cylinders. So let's begin. When we think about volume, we're thinking about how much fits inside of something. So here's a really good example. The amount of water in an aquarium is an example of volume. The volume of a solid is the number of cubic units that are contained in its interior. Now, if you look at this aquarium is kind of shaped like a half cylinder. If we were able to know the height and the radius of this aquarium, we would be able to calculate the volume of water that was needed to fill the aquarium. So let's start with the volume of a prism. In order to calculate the volume of a prism, there's two things you need to know. You need to know the area of the base, and you need to know the height. And of course, those are the same things that you need to know to calculate its surface area. The only difference is we don't need to know the perimeter of the base. So we're going to find the area of the base, whatever that is. We're going to find the height of the prism, and the volume is going to be given to us by the formula, the area of the base times the height. Now remember when we said that volume was equal to the number of cubic units in a figure? So I want you to visualize a prism here. So let's say this is our prism. There we go. And I wanted to find the volume of this prism. Essentially what I want to know is how many little teeny tiny cubes will fit in this prism. And each of these cubes would be 1 unit by 1 unit. And that total number of cubes is the volume of the prism. Okay? So the way we find that is we multiply how many cubes we have this way times how many cubes there are this way times how many cubes there are going up. So length times width times height. And that might be a formula that you've already known about volume of a rectangular prism, right? The length times the width times the height gives you the volume. But if you think about it, the length times the width is actually equal to the area of the base, right? If we look at this picture up here, here's the length, here's the width. So the area of the base is actually equal to length times width in this example. The problem is that only works if your prism is rectangular. What if your prism isn't rectangular? What if it's a triangular prism? Well, in that case, we need to know the area of the base, and then we're going to multiply that by its height. And in this case, the area of the base is not found by the formula length times width. So what this does for us is it gives us a very general formula to find the area of any prism. Then we have to figure out what's the correct area formula for the base. So let's do a couple of examples. Let's find the volume of this prism. We have a rectangular prism. The length is 7, the width is 4, and the height is 5. So if I just look at the bottom of this prism, the area of the base, since it's a rectangle, would be 7 times 4, which is 28. The height is, of course, 5. So the volume of this prism would be the area of the base, which is 28, times the height, which is 5, and 28 times 5 is 140. Now, when we're working with volume, we want to make sure that we include the units cubed. So in this case, it would be inches cubed, or the way we would say this is 140 cubic inches. We write inches cubed, but we say cubic inches. All right, let's do another example when we don't have a rectangle. Let's find the volume of this prism. Here we can see we have a triangular base, and in that triangular base, there's a right angle. So visualize what the base would look like if you just drew a picture of the base. Because there's a right angle here, the base of this prism looks like this, where this side is 6 coming from here, this side is 8 coming from here. And since this is a right triangle, the area of the base can be found by 1/2 base times height, the base of the triangle. And since it's a right angle, we can use this side for little b and this side for the height of the triangle. So that would be 1/2 times 8 times 6, which is 4 times 6, which is 24. In this case, it would be 24 feet squared. So that is the area of the base, 24. The height is 3. So the volume will be found by multiplying the area of the base times the height. So that will be 24 times 3, and 24 times 3 is equal to 72. And again, the units here would be cubic feet. All right, now let's talk about the area, or excuse me, the volume of a cylinder. So the method for finding the volume of a cylinder is exactly the same as it is for finding the volume of a prism. If I want to know how many cubic units I can fit in here, I want to start by looking at the area of the base, and I'm going to multiply that by the height of my cylinder. The only thing is, because it is a cylinder, the area of the base will always be given by the formula pi r squared. So substituting that in for the formula for volume is going to give me the volume is equal to the area of the base times the height, or pi r squared times the height. One thing you want to make sure that you're doing is finding the radius, right? Remember, sometimes it gives us the diameter, so sometimes you have to divide that by 2 in order to calculate the radius. So just pay attention to that. All right, let's do an example. How do the radius and height of the mug compare to the radius and height of the dog bowl? So let's look at the mug. For the mug, the radius is equal to 2 inches, and the height is equal to 4 inches. Excuse me. All right, now let's look at the dog bowl. For the dog bowl, the radius is equal to 6 inches, and the height is equal to 4 inches. So how do they compare? We can see that the heights are equal to each other. They're both 4 inches. So we might write the heights are equal, but the radius, since the radius of the dog bowl is 6 and the radius of the mug is 2, we could say the radius of the bowl is 3 times the radius of the mug. 2 times 3 is 6, so that means that the bowl, its radius is 3 times bigger. So let's see what that does to the volume. You might make a conjecture here. How do you think the volume of the bowl is going to compare to the volume of the mug? The radius of that bowl is 3 times bigger, and the heights are the same. So one conjecture might be that the volume is 3 times bigger. So let's see what happens there. So let's start with the mug. The volume equals pi r squared times the height. So it's going to be pi times 2 squared times the height, which is 4. So that's pi times 4 times 4. 4 times 4 is 16. So that's 16 pi. And that would be cubic inches. Now let's look at the dog bowl. Again, volume equals pi r squared times the height. So that's going to be pi times 6 squared times 4. 6 squared is 36. So that's pi times 36 times 4. And then we have to multiply 36 times 4. And 36 times 4 gives us 144. So the volume of the bowl is 144 pi. So if I want to know how many times greater the volume of the bowl is than the volume of the mug, what I need to do is divide the volume of the bowl by the volume of the mug. So that would be 144 pi divided by 16 pi. All right, well, pi divided by pi is 1, so that reduces. And then 144 divided by 16 is actually 9. So that means the volume of the bowl is 9 times greater. So even though my radius was 3 times greater, the volume ended up being 9 times greater than the mug. Now, why do you think that's happening? Why is the volume of the bowl 9 times greater than the volume of the mug? Well, think about how we use the radius, right? My radius here was 6, my radius here was 2. The radius of the bowl is 3 times bigger. But for the radius, I have to square the radius when I'm plugging it into the volume formula, right? We have r squared here and r squared here. So if this radius is 3 times bigger, then I'm squaring a number that's 3 times bigger. My result is going to be 3 squared times bigger, which is 9. Okay, so that's it for our volume examples. We'll do some more problem solving when we get to class, but make sure you go back, write your questions on the left, and complete your summary for class.